Hi Finxters, good afternoon. First of all, I want to tell you that I have a sore throat, so that's the way it is. No, there's nothing I can do about it. Okay, so bear with me. Maybe I'm even less clear than ever, but that's okay. So today we are going to see how we can write lots of data we generate in our programs for, I don't know, data science or whatever we want. Okay, but that's something that it's expensive to compute and takes maybe lots of time and resources. And it's I think it's a clever thing to save that data into disk for later use. Okay, so if we want to use it several times, we can have it there, and that way it will be much faster and yeah, it's a very good pipeline to have, not to generate every single iteration of our program. Okay, so for example, today we are going to see how to generate and save a list with a million random floats. Okay, it's I just did some a normal distribution with a mu of 0 and a sigma of 1. Okay, so that's a pretty nothing interesting. Okay, but that's what we are going to do. Okay, so we are going to assume let's see this. We are going to import random OS. Okay, random to generate random numbers, OS to read files, and this is at a macro time it in a module called Finxter tools that we're going to have in the web. Okay, so you can use it. It's just to to be concise and everything readable. Okay, so the first naive solution. Okay, I'm going to. I think it's better to copy paste, so you don't have to spend lots of time waiting for me to type. Okay, it's not my strength. So this text, it's I say okay, let's generate this huge list. We set a random seed of 42, and for the sake of this exercise, I wrote one liner. I call it smelly because it's not a good thing to code, but it's short. So what we're going to do is just open the text, the file for writing, and write an empty string. So it's erased. Okay, because for this implementation we are going to append the data we're creating. Okay, so in this case I open and erase the file. And then I say, okay, there's a for loop. I use with open, the context manager for file and a huge list naive1, and I say, okay, let's going to write this string. Okay, so what are we going to write? Well, the output of a random Gauss with with 0 and 1 parameters. Okay, and then we are going to append a comma, so we can have the different numbers appended and separated by commas in the file. Okay, so let's check this. Okay, so generate the let's use this one. Okay, so maybe I don't know if I'm going to pause the video because it's stupid for you to be waiting. Okay, well, or we can say something more. Okay, no, okay, I'm going to pause it. Okay, so we're back. I had time to shave and grow a beard again, so that's it. It says it's like half a minute, 91,000 milliseconds, so that's not very fast. Okay. And yeah, it depends on the iteration, but let's see the file size. you use this, and yes, it's this is the size we got on the disk. Okay, so it's a little less than 20 megabytes, and yeah, we can see. Okay, we can check. We have to do. Okay, let's see. To read the file. Okay, we have to do some tinkering, and we have to, let's see, I made a list comprehension, and I convert to a float every item I get from the file read, except the last character, okay, because the last character was a comma, and then I split it, okay. I don't include the last character because then I will have an empty string at the end, okay, and that would be a mess. And okay, then I check the 24th element. Yeah, is this one, okay. So after doing this, we say okay, yeah, maybe this wasn't the best idea. Okay, we have opened and closed. Okay, this file 1 million and one time. Okay, so that's very cost ineffective. Something I mean, it's stupid. So yes, don't do it. So the second solution, it's yeah, okay, so let's just open it once. Okay, so we'll do this, and after executing it, okay, let's check, and this one should be faster. See, just okay, look at the number, it's beautiful. It's 1 second and 2, 3, 4 milliseconds. Okay, so I think it's it's 90 or 80 times faster than the first implementation. So okay, this one looks I think it looks much better. Okay, so now okay, we can check the file size too. It's the same as it was before. Okay, it was the one before. It's the same, and yeah, we could also recover the data in the same way. Okay, see, it's the same element. Okay, the 40-second element is the same one it was before. But yeah, we think we can really improve it. What we're doing so far is just generating a number and writing it to disk. But that's not really what we want. We want to generate a list of 1 million numbers and write it to disk. So yeah, instead of calling write 1 million times, we're going to try another solution. Okay, we create our list as a list comprehension, and then that's what we dump in the disk in a single operation. Okay, so now if we try it, let's see. It's less than before, slightly less. It should be a little faster. I mean, there should be a little more difference between them, but we're just doing it once, so there's not really that's not a good benchmark. Okay, when we benchmark something, we have to try it several times and get the averages. Okay, so in this case, it's even easier. The random seed, and then we open the file in writing mode, and then we just write the string, okay, of this. I rather use repr instead of str, because this is the representation, the technical representation of the object we pass it. Okay, and the string is just more human readable. In the case of a list, it's the same, but not in other more complicated objects. I rather use this ReadBinary. Okay, it's for me it's a matter of choice, but I rather use it. Okay, So as we say, in this case, let's check. And same thing, okay. We have to modify a little bit the reading back part, and in this case we have to omit the first and the last element, because yeah, in this case we have written also brackets, okay, and in the text file included brackets, but not the last comma, okay. So it's that's the little change. And if you see the size of the file, this one, it's over 20 megabytes, and the ones before were less. This is because we have spaces, okay. The representation is an opening bracket, the number, comma, space, the next number, comma, space, and the last one is the closing bracket, okay. So we have a million spaces that it's making for a million kilobytes in difference. If you see it's 20 and 150, and this one is 19 and 172, okay. So it's it accounts for that, more or less. So no, as far as we know, this is pretty much the best we can do. It's very Pythonic. We are doing things just once, and you know, it looks good, okay. So we say, okay, we can still do something better, that it's to refactor it, okay. So we are going to take away the list generation part and put it in another function, okay. So we can modify the function, and you know, it's better to let every function do just one thing, okay. So this is what we are going to try. Let's see. This is it, and as we can see, you know, we have two execution times, one of the generating list part and one for the writing part, okay. It's more or less the sum of this is the same of the time we had before, but this one looks you know, looks better, okay. We have, as we say, we have we have the huge list. That's what we are going to write, and down here we are calling it, okay. My huge list is calling generate huge list is one, and we are passing the parameters. We're defining it with the parameter size and seed, okay. It has the list size. Well, okay, you can see it, okay. So it's the same thing, but taking it from inside the function, so it's much better, okay. So this looks good, but okay, we're writing a list. What if we want to generate a dictionary, or I don't know, another different data structure? We should be, you know, doing some tinkering with how to dump it and then opening it doesn't look very Pythonic, okay. So we see that okay, let's check, and there goes the JSON module, okay. So okay, you can check the links to if you don't know what JSON is, but basically it's the JavaScript object notation, and it's a format of plain text to exchange very standard data structures, okay. So lists, dictionaries, tuples, or whatever it is, okay. So in this case we are going to do this thing, okay. We are going to import JSON there, and then we're going to time it. In this case it's the writing part. It's a little bit modified, and we have just to do JSON dump the object we want to dump, it's a huge list, and the file, okay, the file string in this case is f. So it's pretty straightforward, and as you can see, the time of the dumping part, it's like 3 times the time of just saving a plain text. So why is that? That's because JSON has to do several sanity checks, and it has to you know, serialize the data in memory to, you know, to be a standard for this. Okay, it's not just dumping, but it has to really elaborate what it's going to save on the disk. Okay, so it's interchangeable with one language and any other, and there's no problem. Okay, so in this case, if we see this the thing, okay, this is the thing before. So let's check whether this is what I want to do. Okay, in this case, the size, okay, it's the same one it was before in our last implementation, okay, with the wrapper. It's because in JSON it's exactly you know, verbatim the same exact file. Okay, so now to get it back, it's a very different format. It's way faster than before, because we just have to say the name of the object we want, and it's JSON load and the file stream. Okay, so it's pretty straightforward, and the 40-second element is exactly the same it was before. Okay, and this getting back the data, it's way faster and simpler than it was before. So, you know, it makes a little bit for the loss of speed when dumping. You are going to save it once, but you are going to use it many times. Okay, and this thing, okay, you can also send it, and there's no problem. Okay, but yeah, this is Python, and we know there must be something else to do this. And then we come to the pickle module. Okay, and this pickle thing, it's you know, it's there are very I don't know, many people doesn't like it and says you know, like bad stuff about it, but I think it's really, it's a great thing to, you know, for our needs, to locally save our data. Pickle, it's just our memory, it's a binary, and then we are going to just serialize it into a serial file stream. Okay, we are not going to convert to data, or we're just going to make it okay, to put it into a serial file. Okay, so it's very fast. We don't have to convert in many weird things, and we can almost save any object, anything, even custom objects or classes or functions or generators, almost everything. Okay, the bad thing is that if we it's not readable, it's just a binary file, and it's not it shouldn't be really compatible with any other languages. And yeah, if because we are just saving real memory state, we could also import malicious code. Okay, so if we are using it for our local files, it's perfect. Okay, so let's check. Okay, so in this case, if you see the execution time of pickle, it's close to, okay, it's less than 1 millisecond. Okay, so it's outside our range. So maybe it's wrong. We had a half-second generation time, but the writing to disk was instantaneous. Okay, we have to import pickle, and in this case we are going to open it as ReadBinary. Okay, we're going to write a binary file, and yeah, it's a pickle dump, the name of the object, the file pointer, and optionally we can state the protocol. Okay, if you use -1 is the latest one. So if there are new protocols, you are going to use always the last one. Okay, and as you can see, it's really fast. And let's check the file size. In this case, it's less than half, or just yeah, like one half of the one we had before. So maybe this is weird. Let's check. See, the same it's the same number we had before. Okay, we just have to open it ReadBinary, and then like JSON, they have almost the same structure. You use you give the number of the object you want, the variable, and then it's pickle load and the file stream, and then you have it in memory. Okay, so this is really fast. I don't know if we use I don't know if it's no, sorry, it's this is what I wanted to show. You can see the sizes of the documents, and yeah, the pickle one, it's really the the shortest one. The other ones, they have just 1 million spaces difference. So this is because this is the as you can see, there's a million characters difference, a million bytes. And yeah, this is what we can get you know, from a vanilla installation of Python for what we want to do. I think it's everything we need to do. Okay, we don't need to use SQL or any other weird way to save our data. This is like yeah, to use and throw is scratch data, and it's a really good way to do it. Okay, and yeah, also for JSON there are third-party libraries that are even faster, are very resilient to you know, not orthodox methods of saving a file, and yeah, they are more flexible. Okay. And yeah, and in the text of the article, and in the text of the article, you can see the complete code with some benchmarks and the auxiliary tool with the you know, with the macro, I think before, but I meant a decorator. Okay, it's a decorator function to time our processes. And I think yeah, that's all for now. I hope you like this video, and see ya.